So in my last video, I started working on this Arduino computer thing. But one thing it seems to be missing is some sort of enclosure, because the wires are kind of just hanging loose, and they've already broken a couple times. So the models just finished printing, and I think they turned out pretty well. The print quality is pretty good, and I don't think I'll have any issues with these prints. We'll just have to see if these electronics fit inside them. Okay, so somehow I managed to fit all the electronics inside this little box. I still need to print the cap that covers this, but that's not done printing yet. Now let's see if it works. And as you can see, it still works perfectly, aside for the screen that is slightly poking out from the thing. Now that we got everything mostly enclosed inside this box, I can start programming the OS for it. So I started working on this assembly type language that the Arduino will read off of the SD card. Before putting it on the SD card, it is going to be compiled into hexadecimal first. Writing this code in this sort of assembly type language and hand converting it into hexadecimal numbers. I think I finally got the processor about 80% working. I've just finished coding this compiler. It basically takes the assembly and converts it into the correct hexadecimal codes that run on the Arduino processor. Let's give it a test and see if it works. So here's some basic code I wrote. Basically what it does is define two variables. It clears the screen with the color black. It sets the draw color to green, and then draws a pixel at the position 0, 0. And then the program ends. So let's see if it successfully compiles. Okay, so as you can see, when I press run, it gives me a huge list of all the opcodes. But we don't really know if this actually works or not, so let's test that. Okay, so what I've done is I basically just copy the code directly over to the SD card without changing any of the code that's on the processor. So let's see what happens when we turn it on. Okay, and as you can see, there's a very tiny green pixel in the top right corner, and that means the code worked. So now that we know that it works, we can try to write something more advanced. I'm on my tablet right now because it's easier to work here than it is to carry all the electronics to my computer. So what I'm going to do is I'm actually just going to walk you through how I write a program and then upload it to the board. So this is the compiler that compiles the code into the hexadecimal, and this is where we write the code that actually runs on the board. So first, we can define a variable. It has some parameters. The first parameter tells you what RAM position it is stored in. So this one is going to be stored in RAM 0. And then next position is what value you're going to store. So we're just going to store a 0. This is going to be an X and a Y position. So then the second one, which is Y, is going to be stored in RAM position 1. And it's also going to be stored a 0. So that's how you define variables. This is sort of an assembly-based language, so it's a bit lower level. I might eventually make a more higher level language, but this is what I have now. The program we're going to create is just going to be a pixel that you can use the WASD keys to just move it around the screen. I don't have a real keyboard for the device yet, so we're just going to use the serial port, and that's going to kind of pretend to be a keyboard. So what we have to do next is we need to create a label. What a label does is it basically tells the computer that that's a position it can jump to. So this is just going to be called start. And then after we can actually jump to it by doing jump start. And what this is going to do is the Arduino actually ignores labels. It actually doesn't even get compiled. The compiler basically just notices that this is a thing it can jump to, and it will save the byte position. So currently the program is going to define the variables in RAM, and then it's just gonna loop inside here. There's no code running right now. So we need to write some code that goes in there. After we create the loop, is we need to actually read what key the user is sending. So we can use the command read byte. The read byte command takes two parameters. The first parameter tells it what port it is going to be looking in. Port 0 is the only one we have currently, and it's just the standard serial port. This is what we're going to be using to create the actual like USB connections, but I don't have that program yet. And then the next position, or the next parameter, tells it what RAM position to store the byte if it actually reads anything. And we already have RAM position 0 and RAM position 1 used, so we're going to store this in RAM position 2. So it's going to read a byte from serial port 0, and store, if it reads anything, it's going to store it into RAM 2. We need to actually do certain things depending on what byte is being read. So the four bytes we only care about is the bytes for W, A, S, and D. Now, we can't just check for the W, because read byte takes in a serial and stores it as a number. So we need to actually check for the ASCII numbers. So I have this chart, and it gives you the ASCII codes of the letters. So the first one we're going to check for is the W key, which would be if the player wants to go up. And that has a decimal number of 119. So we're going to check for that first. So what we have to do is, for an if statement, you use if, and what the if does is it compares two RAM positions. It's kind of a bad way to do it, but it's the easiest way I could make work. So what it does is it takes a RAM position 1. It uses a comparison. Basically that's like checking if it's equal or not equal or whatever. And then it checks, it compares it to a RAM position 2. So I can't compare it to just like a standard number. I need to actually load the number into a RAM position first. So we're just going to use RAM position 3, because that's we haven't used that one yet. So we're going to load the number we want to check for inside RAM position 3. We're then going to run an if statement that checks if RAM position 2, which is the byte we just read, is equal to RAM position 3. If it's equal, it's just going to continue running. Otherwise, we have to put in a label. So if it's false, it's going to actually jump to this. So this is the end of the if statement. We're just going to call it end W, because that's what the if statement is. So now we have this if statement that checks if the serial just read a W from the port. And we actually want to increment the X or Y depending on what we read. So if it read a W, we're probably going to want to decrement the Y value, because that would make it go up. So good thing I have a command called decrement, which takes a RAM position, and it'll decrement it by 1. So Y is stored in RAM position 1, so we're just going to decrement 1. So if it reads a W, it's going to decrement. If it doesn't read a W, it's going to not decrement and jump right into this label, and then hit the end of the loop and restart. So I'm just going to create the if statements for the rest of the letter keys. Just finished writing all 4 if statements. The code's getting pretty confusing because I haven't implemented commenting yet. Even that wouldn't help very much. It's just assembly, usually it's pretty confusing. So we have the if statements. This should work. It should increment or decrement the x and y depending on what letter you press. But nothing's actually going to show up on the screen. So we need to actually make something display onto the screen. So right here in the beginning, before we even read the byte, what we're going to do is clear the screen. Clear screen will take whatever color is currently set, which we haven't set a color. So this just takes an RG and a B. So we're going to set the fill color to black, and then we're going to clear the screen with the color black. And then at the end of the if statements, once we increment or decrement the correct values, we want to draw a pixel. The pixel is going to be the player. We don't have bitmaps set up properly, so the best we can do is a pixel. So the player will just be red, and then we use the pixel command. What the pixel does is takes a x and a y value, which we have. 0 and 1 are the RAM positions for the x and y. So what this program is going to do is it's going to create 2 variables, x and y. It is going to set a start position. It is going to clear the screen with black, check if there is a key being pressed. It's going to increment or decrement the correct values, and then it's going to draw a pixel at the x and y. It's then going to jump back to the start and loop. So this script should hopefully work. So we have this Python script that will actually compile it into a binary code that can run on the Arduino. So let's test that. And as you can see, it compiled successfully, and the program is 95 bytes, which is pretty good size for what we wrote. If you look inside the files, you can see this is the compiler program, this is the script we wrote, and then this binary file called pgm1 or program1, it's our 95-byte binary file. So what we can do is just move this onto the SD card. Normally the SD card should be empty, but when I plug it into the Android device, it creates a bunch of files we don't need. That doesn't really matter right now, though. So now that it's on the SD card, we can actually just eject the card and hopefully put it in the Arduino and see if it works. Okay, so here's our device. You can see that there's only power and ground connected, so there's no data coming in here. And there's currently no SD card plugged in. So when I plug it into power, it shouldn't really do anything besides initialize the screen. Yeah, and then it just stays white because there's nothing on the card. There isn't even a card plugged in. So if I unplug it, and I take just this card, it's just 16 gigabyte. It's the one we put the code on earlier. And I plug it in the back, and without even uploading any code to the Arduino, we can plug it in, and you should see it's flickering right now because of how we wrote it. But it's in the top left corner. There's a flickering red pixel. And when we send keystrokes through the serial, it should move around the screen. Okay, so I've actually just sat there trying to send data through the serial, and then I realized the serial cables were actually desoldered, so I had to solder them on really quick. The only data coming in through the serial is just the keystrokes and not anything else. So if you can see, you probably can't see, but the pixel is just flashing in the top left corner of the screen, and basically I'm going to try to move to the right. And you can see when I press the keys, it moves around the screen. The only issue is I only pressed the right key and the down key once, and it actually continues moving. That's because it doesn't clear the RAM buffer after it reads a byte. So you only press the key once and it continues reading it. So we need to modify the code really quick, which will allow me to move around the screen. So let me do that really quick. What to do to clear the RAM buffer is basically as soon as we get to the end, we just need to clear RAM 2 and just put a 0 in there, and that'll clear the RAM buffer because it reads bytes into RAM position 2. What it's doing is just never clearing it and continue looping. So let's compile that really quick and put it on the SD card. Okay, so I've got the modified program on the SD card, and I'm just going to put it in here. So now when we run the code, hopefully it works. Let me just open the serial monitor and see if it moves, if it focuses. So what I'm going to do is press the right key and press the down key a couple times, and it's really hard to see. Let me see if I can zoom in. Let me move to the right and down again. And as you can see, every time I send a key through the serial monitor, it actually moves. So this would be a good way to make some sort of a game or something, or a cursor that you wanted to move around the screen. I could probably do move a lot of pixels at once, but this is what I can do right now. So yeah, that is how you write programs and put it onto the thing. It's actually quite easy, and I plan on making an entire operating system this way. So we will see how that turns out.